That's it. That's all right.
All right, guys, let's make a start. I'll just...
In your notebook?
Okay, so we tune it in. We've got our laptop away. I just want to talk first about, Raj, the email I sent you guys yesterday just about 1C, the exercise. So a couple of things to say about it. It is an enormous exercise, right? 16 questions. And every now and then we will get an exercise like that where I'll just say, yep, complete it when you can. So 3B is another one that sticks in my mind on tangents and normals. They're just enormous exercises. And it's not like I expect you to get it all done in one night so that you're ready the next day. I understand that's not necessarily feasible. So, I'm going to be very forgiving with what you get done and what you don't. You're a responsible learner. It's up to you to get it done. So I'll just talk about some of these things that I said. So the first thing is, when we're going over the notes, we won't cover every possible type of question that I can ask. Rather, we will cover skills. And in the textbook, is everyone okay? What's going on back here? All right, what I'm saying is important. And in the textbook, we will encounter and develop new skills as the questions arise. So I don't expect you to listen to me and then go and answer every question. My expectation is that throughout your work in the textbook, questions will pop up. You will need guidance from me, from your peers, from the work solutions when I'm not around, and so forth. And that struggle, okay, that sort of wrestling with these questions, that is where the real learning occurs. We could get up here and I could go through every question in the textbook, we could do them all together, but you're learning less and less and less, okay? The more you do something yourself, the more you take on that ownership yourself and struggle through the problem, the more you're going to absorb, the better it's going to be for you. So I was just saying in the test situation how we write a test. From a test, you can expect, say there's 100 marks in a test, 70 marks, 70% of those marks are what we call routine problems. So those are basic skills that I want everyone to have a very competent grasp of. And then the other 30% come from what we call higher order thinking. So that's ones that are a bit more abstract, they're the more challenging ones. And the textbook's set out in such a way that you always have the easier questions first and then the harder questions second, isn't it? So make sure you get a grasp of the first ones, and then just try your very best with the later ones. And in class, we should have the opportunity to go through them together, okay? To either go through them together, or if it's something you want to do, we should have time in class, or else let me know. Very happy to catch up outside of class. And we almost do every question. There's only a few in the textbook that aren't relevant for our course because the course has changed a little bit. And there are other questions that we need to add to it in order to make sure we're completing all of the curriculum requirements. But I will always say do every question because it's that broadest scope will allow the most learning to occur. And I'm always thinking about, for me, it's like ticking the boxes, yes, we've satisfied the curriculum statement in order for the exam. Like we need to cover all this breadth in order for the exam. In a test situation, because it's a short chunk, you're going to know everything to expect in the test, but for the exam, it's everything we've done for the year. So we've got to tick all those boxes, make sure we're prepared in that regard. And so the other thing I've said, you're a responsible learner, and so I'll set lots of questions, but if you look at question one was about graphing, and there were 6 graphs to do over and over and over again. And if you feel this is a skill that you've mastered, my advice is move on. I don't think there's any point doing the same thing over and over and over again. So pick one of the easy ones, yep, I know how to do this. Move to one of the hard ones, yep, I know how to do this. I can skip those ones in between, okay? Have that sort of confidence in yourself. Even reading a question is a good way of knowing, would I know what to do here? Do I know how to solve this? And that can be a great way to learn. Stella? Go.
It's like one booklet can be like what one test is on.
Yes, so this is just background knowledge. This is everything we need to know. The booklet that you'll get on Monday, that's when we're going to start calculus, Tuesday is our next lesson, is on chapters 2 and 3, so that will cover our first 2 tests. Okay, so the booklet is just dedicated to calculus, rules of calculus and applications of calculus, and that will have everything in it that we need. Yeah.
All right, I think that's really all we need to say. I've talked about the solutions. They're there as a prompt, okay? If you're at home and you're stuck, feel free to use them. But if you're really getting stuck and bogged down, maybe time to stop. There's no point doing something over and over and over again if you don't know what you're doing, okay? Waste of time, get yourself worked up. Just stop and come in and chat to me about it. But yeah, feel free to use the solutions as a prompt, here and there and so forth. All right, does anyone have any questions about that? I said that all in an email, basically. Okay, so today then we're going through exercise 1D. It's a beautiful short exercise. It's a recap of the trig and unit circle unit that you did in Year 11 Methods Semester 2. We did a little bit for holiday homework as well. In this booklet, I've got a few extra questions that won't pop up in the textbook, but it is stuff we do need to know as well. So everything in here is stuff that can be asked in an exam. We will start with the unit circle and then we will look at functions. So we'll do both of these today. So we're familiar with the unit circle, we're familiar with these identities that we derive. You do not need double angle identities in Year 12 methods, okay? They're not part of the course that you're required to know. We're familiar with the distinction between degrees and radians and how to convert to them. So let's get straight into our example problems together then. So we've got, given theta is 7 pi on top of 6, find cos of theta, sine of theta, and tan of theta. So we've got a unit circle. I've provided you one for you here. Cos is always the x value, because that's the one it is. Sine is the y value, and then tan is sine divided by cos. So I'll put that up here. For us, that's one of our identities. Sine divided by cos. So we've got the angle, 7 pi on 6. Have a look at your unit circle, and we're looking around at the radians until we see 7 pi on 6. All right, we can see the cos value, negative half. We can see the y value, I'll mix those up. X comes before 1. The cos value is negative root 3 on 2. The sine value is negative half. Okay, you need to make sure you can know how to use the unit circle. Cos value, negative root 3 on 2. The sine value, negative half. And then tan is sine divided by cos. So tan is going to be minus half on top of minus root 3 on 2. Okay, so just whenever we have a fraction like this, we've got a fraction at the top and a fraction at the bottom. This is a really good way to think about it. A on B on C on D will always be AD on BC. We can break it down from like 4 fractions to a single fraction, right? So the top times the bottom, 1 times 2, okay, that will be 2. And B times C, the 2 middle terms, 2 times root 3. All right, A times D divided by B times C. This is a good rule to remember, this one, okay? Now, the other thing is as well, I've got negative at the top and negative at the bottom, so the negatives will cancel. Now, if you do want to process it because you're not sure where the negative belongs, the negative can belong either to the top or the bottom, but not both, okay? So if we're going to put it, I'll just put the negative there on the 1, and I'll put this negative here on the root 3. And then when we multiply them out, right, minus 1 times 2, that would be minus 2. 2 times minus root 3, that would be minus 2 root 3. And you can see we've got negative at the top, negative at the bottom. They will cancel. 2 on 2 root 3. This can be simplified. We have 2 at the top and 2 at the bottom. In fact, what it is, I'm going to write it like this. I'm writing it as 1 times 2, because when the 2 cancels, we're left with 1 at the top. Some people skip that. Some people skip the 1 and they think the answer is just root 3. No, root 3 is the denominator. At the top, when we cancel the 2, we're still left with the number 1. So the value of tan theta, when the angle is 7 pi on 6, is 1 on root 3. Now, all of this you can get from your calculator as well. If your calculator is set in radians, and for this course, it's in radians, okay?
I've never seen a question in degrees. I've never asked a question in degrees. 99% of the time it's in radians. Now, for those that are studying physics, you're going to have to know how to change between the two. But for our purposes, set it in radians. And so if you put in tan of 7 pi on 6 in your calculator, this is what it will spit out for you, 1 on top of root 3. So you can get those straight from your calculator. Very good. Let's move on to question 2. We've got find theta given cos theta is root 3 on 2. Okay, cos of theta is root 3 on 2. Now, just so you know, if you put root 3 on 2 in your calculator, it is about 0.86. Okay? And so I'm going to show you how to think about this, right? We want to know what's the angle that makes the cos of theta equal to root 3. What's cos? It's the x. What's the angle that makes x equal to root 3 on 2? So here's the unit circle, right? And cos is x, and we're saying that x is root 3 on 2. Well, here x is 1, here x is 0. So root 3 on 2, they're going to appear here and here on the unit circle. We're looking for the angle such that the x value is root 3 on 2. And here, root 3 on 2. So have a look at your unit circle. The angle is pi on 6 and 11 pi on 6. Okay, now that would be to answer the question for 1 revolution. Okay, we've answered the question for 1 revolution of the unit circle. However, it does say between 0 and 2 pi, so that's correct. We don't need to consider multiple solutions. Between 0 and 2 pi, that's within 1 revolution. These are our answers. Now, the reason I know to answer in radians is because the domain, the constraints for this problem are stated in radians as well. So that's why I've answered the degree in radians, and we don't consider degrees. Good. Let's move on to B then. If people are happy with that. We have 2 sine theta equals 1. Okay, 2 sine theta equals 1. Now, for this one, up here you saw we've already got the angle by itself, the trig identity by itself. Here we need to break it down to get sine theta by itself. So the first thing we'll do is divide both sides by 2. Sine theta is half. And so if you think, what we're doing then is we're looking at the unit circle. Sine is the y value. Okay, so here y is 0, here y is 1. And we're saying, when is the y value half? So we know where to look on the unit circle. We can figure that out. If the y value is half on the unit circle, that's going to be here and here. So we're looking for coordinates such that the y value, not the x value, the y value is half. So what does that correspond with on our unit circle? We've got pi on 6 and 5 pi on 6. Now, I will show this actually. So this is for, again, 1 revolution, right? We're starting here and going around 0 to 2 pi. If we want to answer for every possible solution, okay, so going around the circle an infinite number of times, remember, okay, what's going on here? If we have a sine graph, it's like this. It's periodic, it keeps repeating. And so when is sine equal to half? Well, it's here and here. That's your pi on 6 and your 5 pi on 6. But it keeps repeating. It keeps repeating every 2 pi. And so the way we would answer is we would say plus k2 pi. And I'll explain what this means. This will be new to many of you. Okay, so what we're saying is we're saying plus k2 pi, this symbol here means for all values of k that belong to z is the set of integers. Okay, set of integers mean k is 1, k is 2, k is 3. And so what that means is 1 wavelength, 2 wavelengths, 3 wavelengths, up to an infinite number of wavelengths. If we add this on, this is it, okay, k2 pi, for all k belongs to integers. This includes every possible solution. All right. Now there have been problems, exam problems pop up like this, so we're touching base with that. Sine of theta is half. This is the solution within the first revolution. This includes every possible solution. All right. Everyone okay with that terminology? Okay. Very good. On to C. We have 3 take 4 sine squared of theta is 0. So our first step is to break this down. We want to get sine of theta by itself. Okay, so we'll subtract 3 from both sides. We will divide both sides by -4. And then we will square root both sides. So we'll have sine of theta, and that will be plus or minus the square root of 3 on 4. And I'll just simplify that using surd operations. So we have sine of theta is plus or minus root 3 on 2. So, how to localize our solution? Remember, sine is the y value, and root 3 on 2 is about 0.8. So we're saying when is the y value positive root 3 on 2 will be these two solutions. Negative root 3 on 2 for the y value will be these two solutions. So we're going to have 4 answers within one revolution such that the y value is positive or negative root 3 on 2. Okay, in this circumstance will be the negative case, and when it's above the x-axis, that's when we have the positive values of y, isn't it? So we'll answer that, root 3 on 2. Have a look at your unit circle. Okay, make sure you follow along there. We can see we've got root 3 on 2 for sine. We have pi on 3. We've got 2 pi on 3. We've got 4 pi on 3. And we've got 5 pi on 3. And that's for, and then we'll include every solution as well. Okay, for all k, e, z. All right, so we're pretty happy with those, I think. Okay, let's move on to the next one then. So we've got find cos and tan given sine theta is 3 on 5. So all of these questions have popped up in our holiday homework, so nothing new here. Let's go over this. We'll talk about the 2 strategies that we can use. So we have sine of theta is 3 on 5. 5. And we've got a constraint for the angle. Pi on 2 is less than theta is less than pi. So it's talking about this quadrant between pi on 2 and pi. Our answers for cos and tan exist in this region. Now, 2 strategies we can use. Both of them will work out absolutely fine. The first is that sine squared theta plus cos squared theta equals 1. This is the Pythagorean identity. All right, I'll just explain quickly where this comes from. If we take a triangle here, okay, on the unit circle, the radius of the unit circle is 1. The x value is cos theta. The y value is sine theta. And Pythag says a squared plus b squared equals c squared. Cos squared theta plus sine squared theta equals 1. That's an identity we will use, one we do need to remember. And so from here, we can just put the 3 on 5 where the sine is, square it. We've got plus cos squared theta. And now we're just solving this equation for cos squared theta, or for cos of theta. We'll try and break it down to get the cos of theta by itself. So my first step will be, I'll square it first. I'll have 9 on 25. I'll subtract 9 on 25 from both sides. Now, these kind of fraction operations are important. Let's talk about that specifically. 1 take away 9 on 25. You can put it in your calculator, but 1, we need this to have the same denominator before we can perform that, right? So that's 25 on 25, take 9 on 25. 25 take away 9 will be 16. Once they have the same denominator, it's just the top take the top. 16 on 25, so we have cos squared of theta is 16 on 25. We will square root both sides. And again, I'll do the third operations. Break it up. Square root of 16 and the square root of 25. 4 on 5. Okay. And so that's all good. We've got two solutions, don't we? We have positive 4 on 5 or negative 4 on 5. And so now we need to consider the domain. We're talking about this region specifically. So one of these answers is wrong. We have cos theta is positive 4 on 5 or it's negative 4 on 5. In this region, cos values are negative. Okay? All the x values are negative. And so that means in this region, all cos values are negative, and so we reject the positive solution. This does not exist in the region we're talking about. This is our answer. Negative 4 on 5. So that's the cosine value. We need the tan value as well. Now, two parts you could take from here. Tan is just sine divided by cos. Alright, so we could just do that. We've got the sine value, we've got the cos value, and we can just divide them. Alright, but I might just go over again the triangle procedure that we've talked about, which is the same way, another way of solving these problems. So for all of these problems, right, where you're required to find one of the unknown trig ratios, this is another strategy you can use. We can sketch a right angled triangle. Any right angled triangle. I'm going to call that theta, and this is my right angle. And this is helpful because it revises the trig, right? If we label this triangle, we've got the hypotenuse, the adjacent side, the opposite side. Okay, the hypotenuse is the longest side, the adjacent connects the right angle and theta, the opposite side is opposite the angle. We know how to do that. Now, we are told in the question, we are told sine of theta is 3 on top of 5. Now, think back, year 9, when you're learning trigonometry. Sok, kat, toa. Sine is O on H. Cos is A on H. Tan is O on A. Sok, sine is O on H. So 3 on 5 is equal to O on H. That means this triangle that we're talking about is in the ratio of 3 on 5, right? O corresponds with 3, H corresponds with 5. Now, we are asked to find tan theta. We need to find tan theta. Tan is O on top of A. Tan is O on top of A. So we need the adjacent side. Okay, we need to find this one. Alright, so let's do that. If we're going to find this, let me just remove those things to make it less confusing for you. We've got this is 3 and this is 5. We need to use Pythagoras' theorem to find this unknown. We would have a squared plus 3 squared equals 5 squared. Okay, solve through for a. 5 squared, take 3 squared. We can square it at some point, doesn't matter when. And we have, 25, take 9. And that will be 16. So we determine a squared is 16. So a is plus or minus 4. Tan, okay, so we've got, if we go back, we can now label this triangle. That is 4. Tan is O divided by A. Tan is O divided by A. So tan then would be 3 divided by plus or minus 4. Again, we've got two solutions. So it's either positive 3 on 4
or negative 3 on 4. We've got to consider the region. So for the unit circle, this is the good way to remember it, right? All students talk cool. What this means, in the first quadrant, all trig ratios are positive. In the second quadrant, only sine is positive. Cos is negative, tan is negative. So that means our tan value in the second quadrant has to be negative. We reject the positive solution because it's outside the domain. Okay, so we've got our answer for tan. So you can use either of those strategies, right? You can use the Pythagorean identity or you can use this triangle strategy. They're both the same. Very good. Okay, let's talk about the functions then. Let's move on to the trig functions. So we have basic trig function. We have A sine B of x take C plus D. So we'll talk about these and how each of those affects it. A is the amplitude. So let's fill in this table. The amplitude is the number out the front. Amplitude, period, is our first function, 2 sine x. Our second function, 1 on 3 sine 4x. And then 0.5 of cos of pi on 3x. Okay, and we're just asked to input the amplitude and the period. Alright, the amplitude is the coefficient out the front. It's the distance from the principal axis to a peak or a trough. This will be 2, this will be a third, this will be 0.5. You're just taking that number. That is the value of the amplitude. It's a magnitude, it's a size. Next we have the period. The period is the distance for one whole wavelength. And the period, the formula for period, is 2 pi divided by b. 2 pi divided by b. b is always the coefficient of x, the number in front of x. So in our first circumstance here, what's the number in front of x? 1. 2 pi divided by 1. The period is 2 pi. It is 2 pi units. What's 2 pi? 6.28. 2 times 3.14, 6.28. 6.28 units for one whole wavelength. Okay, here the period will be 2 pi divided by 4, because the coefficient, the number in front of x here, is 4. 2 pi divided by 4, and we can simplify that to pi over 2. Okay, the period is pi over 2, 1.57. Alright, and then we have 2 pi on top of pi on 3. Okay, so you could put something like that in your calculator, 2 pi divided by a fraction of pi on 3. But here's how we should think about it. 2 pi by itself, well, that's the same as 2 pi on top of 1, isn't it? 2 pi is, well, it's just 2 pi divided by 1. And now we can do our AD on BC. This will become 6 pi on top of pi, which would simplify to 6. The period of the third wave trig function is 6. It's 6 units for one whole wavelength. Okay, let's have a go at these beautiful functions. Sketch of them. We have 6, we have 2, and we have 2 pi, and we have 4 pi. Okay, find the equation of the following trig functions. So what we want to do is we want to try and identify how have they changed from the basic. This one's going to be a cos function, and the second one's going to be a sine function. And so we need to ask ourselves, how much has it been shifted up? How much has it been shifted across? How much has it been dilated? So I'll refer you to the notes under the trig function part there. We've got A is the amplitude. That's the distance from the principal axis to a peak or trough. Now the principal axis is this invisible line here. It's the line about which the trig function propagates itself. Okay? That's what we call the principal axis. And it is always halfway between the peaks and troughs. Okay? That's a peak, that's a trough. The principal axis is exactly halfway. The equation of the principal axis in our first circumstance will be 4. So, we need to find the values of A, B, and D. We will never ask one with C. With horizontal translation, they get a bit confusing. So I've said D is the principal axis, and it also corresponds with how much it's been shifted up. So the basic sine function, right, I'll sketch it here. The basic sine function starts here. Our sine function, this is a cos function, sorry. The basic cos function starts here, at 1. Our cos function starts at 6. Alright, it's been shifted up from 0 to the principal axis here, has gone up 4 units. So our value of D is 4 because it's halfway. Maybe a better way to think about that. 4 because it's halfway between the peak and the trough. Okay. The amplitude then is this distance. From 4 to 6, we have a distance of 2. The amplitude is 2. And then the value of B, there's 2 ways we can think about this. The best way is to go, how many wavelengths are there in 2 pi? There is half a wavelength in 2 pi because we have a full wavelength. Guys, Harry, Jack, we have a full wavelength in 4 pi. Alright? So if we have a full wavelength in 4 pi, we have half of a wavelength in 2 pi. The value of B is half. The equation of this trig function is 2 cos of half x plus 4. Okay, we have the value of A, we have the value of B, and we have the value of D. I'm just plugging in there respectively. Alright, and last one. We have an x-axis here. We have -3 is where the sine function starts. And we have this point here is 2 pi. We have 3 whole wavelengths in 2 pi. Is there anything else that's included? This corresponds with -1. This corresponds with -5. Okay. And I've said this is a sine function. Sine function because it starts at the principal axis. The cos function starts at the peak, so we know this is a sine function. We need the value of A, B, and D. Okay, D is -3. That's how much it's been shifted down from the base function. A, the amplitude, distance from the principal axis, which is here, -3, to a peak or to a trough. Amplitude is 2. We're going 2 units in that direction, 2 units in that direction. And the value of B, how many wavelengths are there in 2 pi? 1 wavelength, 2 wavelengths, 3 wavelengths in 2 pi, and so the value of B is 3. There are 3 whole wavelengths in 2 pi. So we'll have here 2 cos 3x, take 3. Okay. Alright, so we've recapped basically everything you did in trigonometry in the 11 methods there. So, you know, that takes a fair while, but these are skills that are essential for the rest of the year. We're setting you up there. The textbook only asks about 5 or 6 questions, so that's where we'll dedicate our efforts today, and then we've got sort of the lesson, you know, to finish that off, do some of 1C, ask some questions and so forth. Alright, so let's pull that out. 1D, I'd like